Hi, welcome to the fun probability problem solving sections. And the problem we try to solve today is a little bit of challenge, but it's fun. So let's take a look here. So let's say if x is a non-negative integer value, the discrete random variables. First thing is we want to prove the expected value of x is equal to this summation I from 1 to infinity, and the probability x greater than equal to I. Now we're going to use this result and try to solve the part B here. The part B here said A and B play a chess game. The probability A win is P, and the probability of the B win is 1 minus P. So I want to find the average number of the games played until one player win 2 games in a row here. Okay, so now let's go ahead start. Like I said, this problem is kind of a little bit tedious and complicated type of problems. Okay, so let's go ahead and go to our whiteboard and let's try to solve the first part here. The first part of our questions here is we want to prove is the problem we try to prove is the expected value is equal to the probability. So it's a summation I from 1 to infinity probability the x greater than equal to I here. Okay, all right, so let's go ahead and start here. Okay, so the first things here, all right. So the part A is a kind of compared to the part B is a little easier. Okay, so let's see here the probability P greater than equal to I from 1 to infinity, right? So really we're looking for the P probability x greater than equal to 1 plus the probability x is greater than equal to 2 plus probability x is greater than equal to 3 and all right, and now okay, so now let's see here. So let's take a look see here. So take a look at the first probability x greater than equal to 1. Let's write it here. So probability x greater than equal to 1. So if you want to write it, so this will be equal to what? It's equal to the probability x equal to 1 plus the probability x equal to 2 plus the probability x equal to 3 and plus the probability x equal to 4. All right, and the same things here. If you see the probability x greater than equal to 2, then I can write it x greater than 2, so it's a probability x equal to 2 plus the probability x equal to 3 plus the probability x equal to what? Equal to 4, and then go continuous, right? So let's take a look one more, then maybe you will see. So this is a probability x greater than 3 here. If this one's here, that means x equal to 3 plus probability x equal to 4 plus One more, you will see the pattern. So like probability x greater than equal to 4. So this one's here, it will be probability x equal to 4 plus probability x equal to 5, right? And continue. And then here, okay, so the last things here, you say, okay, so I'm going to add all this together. If you add this together, right, so that means I'm adding all this, So that will give me the summation I from 1 to infinity probability x greater than equal to I. So what is here? You have 1 probability x equal to 1. Then how many probability x equal to 2? You have a 2 times probability x equal to 2. Then how many you have x equal to 3? You have 3, the x equal to 3, right? Then you have how many 4? You have 4, the probability x equal to 4, right? Okay, and then you da. So you see here, right? So you see this is 2, 3, 4. So because x is a whole number, so if the PMF, okay, so here, if the PMF of the x here, right, so it's a whole number, right? So this is 1, 2, 3, 4, 5. And then we know this is P1, P2, P3, P4, P5, So based on the expected values here, so what is here? You use the 1 times P1, right? Plus 2 times P2, plus 3 times P3, So this is exactly, so it's P is extra 1, so it's 1 times 1, 2 times P2. So that is how do we prove this is equal to the expected value of x. Okay, so the first part is pretty simple and pretty easy here. Okay, so now I'm going to, let's go to take a look, the second parts here, all right? Go to the next, and go to the next pages here, all right? So let's take a look. Some, I want to do here, get a few probability tables here. And I want to show you the patterns, so you'll be able to see the patterns here. Okay, so for here, the first part here, the first two, this is the A. I have 2 people, right? So the A will win. So this is the A is winning at the first one. So this is the B going to win the first game here. Okay, so now let's take a look. If A win the first game, let's take a look at a few situations here. So you could have AA, right? So both of the A and A's win, so they win the 2 games, right? So what is the probability? P squared. So also they could have A, right? Then B, right? So let's continue games A here. Oh, so what is this one here? The probability is P3 times 1 minus P, right? So how many games this one's here? This game is 2. How many games this one's here? This is 4. Okay, let's take a look at one more example. So then you will be able to see the patterns here. So how about AB is continuous, right? So then you have AAs here. Okay, so here I have 1, 2, 3, 4. So I have 1, 2, 3, 4, right? So I have a P is equal to 4, then B is 1 minus P to the square. So how many games I need to play? I need to play 6 games. So as you can see, if A starting, all right, so here, this is the A starting and A win, right? So this is A starting and A win. So how many here? Like we have could win is 2 games, 4 games, 6 games, 8 games, then . So 2 games will be P to the square. 4 games will be P3, 1 minus P, and the 4 games will be P4, 1 minus P to the square, and the A games will be P5, 1 minus P to the third game. So this part is here is A wins, right? So A start, So this one's A start and A win. Okay, that's this tables here. Okay, so this is the average game. So this is A start, right? A wins. So I do the first ones here, right? So now A start win and the B win here. Okay, so here let's take a look here. So for these situations here, it will be A, then B, B, right? So what is the probabilities here? It's P 1 minus P to the square. How many games? 3 games here. Okay, now let's take a look one more. You say AB, oh, then A, B, B. So B win again. So how many probabilities? P square, 1 minus P to the what? Cube. How many games here? 5 games, right? So let's see one more. So you say A, B, A, B, A, B, B. B win again, right? Because the last two is. So how many? I have 1, 2, 3. So I have a P3. Then 1, 2, 3, 4 is 1 minus P to the what? 4. So how many games here? 7 games. So this is the probability of the B going to win and the number of the games, right? So now you see, so what is here? So this will be 3, 5, 7, and then 9, and the da. Let's see what is the probability here. This is the P, and this is 1 minus P to the square. Then the next one, this is P square, 1 minus P to the cube. 7 is P cube, 1 minus P to the what? Fourth, right? So what is the ninth here will be P fourth, 1 minus P to the fifth. So did you see the patterns here? So this is when we A start out win the first part, right? So this is when the A start out win the first part, and but finally, which one wins here? The A win and the B win. So this is a two situation. Okay, so the same way we have the situation B start off to wins, right? So B start. So let's see here. So this is B, and I want to A win. So what is the situation? BAA. So what is the, so it's a P square, 1 minus P, right? So how many games here? 3 games, right? Or we can say BA, right? So A win again. So let's see here is the P to the cube, 1 minus P to the square. So how many games here? 5 games here. Let's try one more. So this is BA. Okay, so how many games here? 1, 2, 3. 1, 2, 3, 4. So it's a P to the 4, 1, 2, 3. So how many games here? 7, right? So here, after you see here, I'm starting out right now, the B winning the first time, and till the end, what I'm winning here, till the end, you know, the A is winning. Right? So this is A is winning here. So let's make sure we don't confuse it, right? So this first one, this is A win when the A start. This is A win when the B start, right? Okay. So now you see here, this is 3, 5, 7, 9, da. So what is the probability here? This is the P square, 1 minus P. Okay, and then this is a P cube, 1 minus P to the square. Then this is a P fourth, 1 minus P to the third. Then this is a P fifth, 1 minus P to the what? To the fourth, then da. All right, so now let's take a look at here. I'm starting with a B, and about now I'm going to be a B win. So it's the first situation is a BB. So what is this one here? Is 1 minus p to the square. How many games? 2 games. All right, so this is BABB. Oh, okay, BABB. So here, this will be p, 1 minus p to the cube. How many games here? 4 games. Let's do one last one. BABABB. All right, so here, how many games A win? 2. Then it's 1, 2, 3, 4. So it's 1 minus p to the 4th game. 4. So what is the game? 6. So this is B wins, right? That means here I'm starting out with B win, and at the end is B wins here. Okay, so now let's try to write here. So you see here it's 2, 4, 6. Oh my gosh, right? So this is a 2, 4, 6, 8. Okay, so now you can put this is 1 minus p to the square. Then this is p 1 minus p to the what? Cube. Then you have a p square, 1 minus p to the 4th. Then you have a p cube, 1 minus p to the 5th, and continues, right? So let's be careful. So here, this is A win, the second part, this is B wins, right? So this is B wins here. I want you to see the situation. So like in here, this is 3, 5, 7, 9. Then this is a 2. See here, if you combine the B, so you'll get a 2, 3, 4, 5, 6, 7, 8, 9. So the same way, if you combine the A's here, you will get a 2, 3, 4, 5, 7, 6, 9, 8. And they're all going to combine into a very, very nice forms here. Okay, so now let's go to the next page. So I'm going to combine the table, right? The A win table, these two, the first one, the third one, and the second one and the fourth one here. All right, so you will see it's really very beautiful. It turns out, right? So here, okay. So now, okay, so I'm going to combine here. Okay, so I'm going to combine. Okay, so this is the one I'm going to combine the A win. Okay, so I'm going to combine from the previous page. So I'm going to combine both tables for A wins at the end. And these ones here, I'm going to combine the B win at the end. All right, so you will see after you put them together, you will see it's really beautiful. So this is 2, 3, 4, 5, 6, 7, 8, 9, da da da. This one is the same thing. You have 2, 3, 4, 5, 6, 7, 8, 9, da da da. It's here, right? So this is a p square, and this is a p square 1 minus p. Then this is the p square 1 minus p, p cube. This is a p cube 1 minus p. So p square, and so this is the p cube 1 minus p, and this will be p cube 1 minus p to the square. Then this will be p fourths 1 minus p to the square. Then p7 is p fourths 1 minus p to the cube. And the 8 is p fifths. Okay, so I'm gonna give them a little bit more space. So here, so this is given the p7th here, this will be p fourths 1 minus p to the cube. Then P8, it will be P5, 1 minus P to the cube, that is 9. So as you can see here, right, every, the odd number and the even number, so this is P2 and P4, P6, and 7, then odd number is P square, P cube, and they add up. Okay, so now let's do the B when I combined here. You just merge that two table. My first one is 1 minus P square, and the P, this is 1 minus P square, and the 4 is 1 minus P to the third, the P. So 5 is P to the square, 1 minus P to the third, and the 6 is P2, 1 minus P to the fourth, and the P7 is P3, 1 minus P to the fourth, and the P8 is P3, 1 minus P to the fifth. So basically, what you need to check, just like I'm combining the A wings here and the B, just combine the 4 tables into 2 tables. All right, so here, after I combined it, now I finally be able to try to find the probabilities, right? So we going to, okay, so now in here, let's take a look here. So we know from the part A, from the part A here, I know the expected value is equal to summation I from 1 to infinity probability x greater than equal to I. Okay, so that means, all right, so here that means I'm going to have a probability. Okay, so here that means the probability x greater than equal to 1. Okay, so x greater than equal to 1, just like we said, this is x equal to 1 plus x equal to 2, and to the infinities, right? So I know this is you add all this, see here, your A could be 2, 3, 4, 5, 9, 2, 3, right? So I know you add all this one will be equal to what? This one equal to 1. Okay, so now the probability x equal to 2, so it's the same things, right? So this is the probability x equal to 2 plus probability x equal to 3 plus . So see here, the combined A wing and the B wing, they both the random variable start to 2, 3 to the infinity. So this one will be equal to, so this one will be equal to 1 also, right? Okay, so now let's take a look at how do I do the probabilities here, okay? All right, so now let's take a look here. Okay, so the next page is here. Okay, all right. So from the previous one, we know the probability x greater than equal to 1, probability x greater than equal to 2, equal to 1. Okay, so now I'm going to find the probability x greater than equal to 3, right? Greater than equal to 3 will be what? Greater than equal to 3. Okay, so let me do this here. So you can see the probability x greater than equal to 2. This one is the probability, right? X equal to 2 plus the probability x equal to 3 plus the probability x equal to 4 and right? Then the probability x greater than equal to 3 is equal to the probability x equal to 3 plus the probability x equal to 4. Okay, so now, okay, so see here, right? So now for the probability x greater than equal to 3, what can I do here? I can really write this because they are only different than the ones, right? So it's really is a probability x greater than equal to 2 minus probability x equal to 2, correct? Right, because they only missing here. The only differences here is these numbers, right? So that's why I would say it's probability x greater than equal to 2 minus probability x equal to 2. And we know this is equal to 1 because all the random variables start from 2, 3, 4, 5, right? So what is these numbers here? Okay, greater than equal to 2. So I know the first one is 1. So what is x equal to 2 here? Okay, go back to your combined table. All right, so take a look here. X equal to 2. So here, this is the probability x equal to 2 when A win, or here, this is the probability x equal to 2 when the B wins, right? Okay, so now in here, I can say I will minus p squared minus 1 minus p squared. All right. Okay, so now this is 1 minus p squared. You FOIL this one is minus 1 plus 2p and minus p squared. Okay, so in here, then you say, okay, 1 and the negative 1 cancels, right? So I'm going to have, this is the 2p minus p squared minus 2p squared. So what I can say this is a 2p, 1 minus p. Okay, so let's highlight these ones here, right? So this is okay. So now let's take a look at the other ones here. So then you will see the patterns here. Okay, so now how about the probability x greater than equal to 4? X equal to greater than equal to 4 is just like the probability x equal to 4 plus the probability x equal to 5 and right? So you use the same thing. The 4 and the 3 is only missing here. So I can rewrite x greater than equal to 4 will be equal to what? Will be the probability x greater than equal to 3 minus probability x equal to 3. Right? So you add all these things together and you just get rid of this term. So that's why it's become x greater than equal to 4. Correct? Okay, so we just calculate greater than equal to 3. Right? So the greater than equal to 3, we just calculated that is equal to what? 2p, 1 minus p. All right? So now x equal to 3. I need to get rid of x equal to 3. Go back to here. Take a look. X equal to 3. So this term is x equal to 3, right? So it's p squared 1 minus p. And this term equal to x equal to 3, right? So it's p times 1 minus p squared. All right, so now in here I'm minus, okay? So I minus p squared, 1 minus p, and minus p, and 1 minus p squared, right? Is from my previous table, those light green circles, right? So I minus it. And then you do a little bit, you FOIL that and you do a calculation, you combined. It's very beautifully, it's going to combine to the 1 minus p. Okay, let's do a couple more. Now I think you will see the patterns here, right? All right, so now let's see here, probability x greater than equal to 5. So x equal to greater than equal to 5, just like follow the previous one, will be x greater than equal to 4 minus what? Minus probability x equal to 4, right? So from the previous one, we calculate greater than or equal to 4 is P1 minus P. Okay, now let's go back to my previous x equal to 4. Okay, so what is x equal to 4? This term is P cubed 1 minus P, and the 1 minus P cubed, the P is here. Wow, it's really look out pretty good, right? So this is minus P cubed, right? This is 1 minus P and minus 1 minus P cube to the P. Then you do your algebra and you will get, you FOIL that out and simplify it. You will get this is 2P squared, 1 minus P squared. Okay. One more, you will see the pattern. Okay, so now let's do one more here. So this is the probability P x greater than or equal to 6, right? So you will see here, okay? So you will see here, this will be the probability x greater than or equal to 5 minus the probability x equal to 5. Correct? Probability greater than 5 is 2p squared 1 minus p the square. Okay, let's see the x equal to 5. Okay, so the x equal to 5, let's use this brown color is p3 1 minus p squared and the p2 1 minus p squares, right? Okay, so here, so you minus P3 1 minus P squared minus P squared 1 minus P cubed. All right, so simplify and FOIL, and you will get a P squared 1 minus P squared. And you should see the reason why I want to color code it. See, as you can see, if it's x great, is an even number, it's going to be a geometric series like this. If it's an odd number, it's going to be a geometric series like that. Okay, all right. So now we finally can do that. Okay, so we finally be able to. Okay, so here, this is the, okay, so the expected value of x, right from the part A, we say is a summation I from 1 to infinity, probability xi greater than 1. So I'm going to separate this one. One is for the odd number, one is for the even number. Okay, so for the odd numbers here, x greater than 1 is 1, right? Okay, so x greater than 1 is 1 plus greater than 3 is 2p1 minus p. Greater than 3 is 135, right? So this is 2p squared 1 minus p squared, da, 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 da. So this will be, let me color code that. This is the one. So this is the probability x greater than equal to 1. And then this is the probability x greater than equal to 3, as you can see here. And this is the probability x greater than equal to 5. So this is my even odd numbers. Right now, I can also add my even number. My even number is 1, okay, greater than equal to 2, then greater than equal to 4 is a plus p, 1 minus p, and greater than equal to 6 is p squared, 1 minus p squared, and da, 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 da. So this one's here, this is the probability x greater than equal to 2. This is x greater than equal to what? 4. This is x greater than equal to what? 6, right? So as you can see, I can separate them into two parts here. All right. So now let's go to the next page. It's here. So okay, let's do my odd number part, right? So we'll say is equal to the 1 plus p 1 minus p plus p square 1 minus p square da 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 da. So then plus the even part. So this is the okay. Let me not confuse. So here the odd part, right? So it's 1 2p 1 minus p plus 2p square 1 minus p square plus 2p cube 1 minus p cube da da da. This is my odd. Then my even will be 1 plus p 1 minus p plus p square 1 minus p square. So each one of them, right? So this is my odd ones here. So each one of them is what? Will be a geometric series. So for these ones here, so all this, I can do this is 2. All right, so I factor 2 out. So this is 1 plus p, 1 minus p, plus p square, 1 minus p square, da 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 da. But in here, because this is ones, right? I times 2, so I need to minus ones here. Okay, don't forget this one. Then this is my even number terms. This one is pretty easy. This is just a simple geometrics with the, the R ratio is just P, 1 minus P's, right? So the sum of these ones here will just be 1 minus R, so it's 1 minus P, 1 minus P, right, to the 1. And for these ones here, okay, so these ones here will be the 2. Then inside here is geometric, so it's 1 minus P, and minus 1. So now I can combine all of them together, right? So now these 3 terms, right? So finally, common denominator is 1. I'm sorry, this is 1 minus, I'll try to do it too quick, right? So this is 1 minus P and plus P square. Okay, so this is the 2 minus 1 plus P minus P square. This is minus 1, then plus 1. Okay, so here, okay, so the final answers here, this will be 1 minus P plus P square. So this one will be, so this is a 2 minus 1 plus P minus 1 plus 1. Okay, so, all right, so now here cancel. So this will be 2 plus P minus P squared. All right, so this will be our answers here. Okay, so it's very interesting. So if you let the P, for examples here, if you let the P equal to the 0.5, that means, you have an equal chance to win the games, right? So you have each one, they have an equal chance. If you put a 0.5 into your equation, you have the 2 plus 0.5 and the minus 0.5 to the square, then divided by 1 minus 0.5 plus 0.5 to the square. See here, you will have the expected is 3. So it's very reasonable because if they have a half and half chance to win, so this will be the longest game. So like it could be A, B, so the expected game because of the A, so it could be like a AA and or like A, B, A, right? So the expected will be 3. So it's kind of like a pretty reasonable assumptions here. All right, so that is, so that's the one way you can check if they said they have an equal chance to win. So average, because so on average, so will be 3 games here. All right, so that's what we said expected mean. So well, on average, it will be 3 games. So like if one person have a way higher the probability to win. So for example, A has way more than 0.5, then the expected gain will be less than 3 games here. All right, because the one is have a higher chance to win here, so it has to be less than. If you don't believe, you can go ahead, try to check. So for example, like if A has a very, very high chance to win, it's 0.9, and so it should be very, so it's 2 plus 0.9, okay, minus 0.9 to the square, then divided by 1 minus 0.9 plus the 0.9 to the square, and you will get about, so the expected gain, so expected number of the gain will be about 2.3, all right, or 2.29, so it's 2.3. So it's kind of like, it's kind of intuitively is true, right? Because if A has such a high chance to win, so I expect, right? So probably it's just AA, right? So because that will be the, the winning games here. So that's why when the one person have a high probability to win, then the expected number will be pretty close to 2. Okay, so that's it. It's a very tedious game, but it's very interesting because the results, if you substitute the real life situation, it's kind of like makes sense here. All right, that's it. Okay, hope you enjoyed it. It's very long, and hope that you get a good understanding about how this is done. And it's not hard, it's just very tedious. It's a lot of algebra involved here. All right, sounds good. I guess so. We'll talk to you in the next time. Bye.